Good afternoon, how are you? Can you hear me? I want us to start our session this afternoon. I hope I'm audible enough. Yeah, so get ready. We are doing question and answer on what we call air and combustion. So have your notes in place, 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 put your notes in place, get ready. I can see some of you are already in class. How are you, Anne? And it's been long. Go up, Anne. Anne, where are you? Yeah, we are doing what we call air and combustion, question and answer. Mine is to ask questions. Students are the ones to answer questions. For today, Anne, you will be a student. For the next few hours, you will be my student. Yeah, so yeah, I'm inviting some guys here to join our lesson so that we can proceed together. I can see some of you are already in class. Thank you for that. We have two categories of students. Kuna wale wako kwa Google Meet, kuna wale wako kwa YouTube. All in all, to keep on inviting the others. Me from nitaenda kuuliza maswali za air and combustion. Kasi yako ni those who can hear me. Am I loud and clear? Loud. You tunaweza ajana na lesson. Yeah, hand please do so. Well, thank you for wishing me a nice session, Madam Monkeli. Sawa kabisa. So now we can proceed with the lesson. Are you ready to get the questions? Those who are in and are doing chemistry, but I'm told chemistry is a must. Almost in the old schools in Kenya, chemistry inakwanga the must. Kuna watu wengine chem ingekuwa optional wange drop, but no, that's not you. That's not you. So can someone comment yes so that we can start? Juliet, we want to start right now together with Timothy. We want to with your notes and questions. I will be asking kasi yenu nikujibu tu fasta kidogo na tuende mbio kidogo. Air and combustion. First of all, I want to start by asking, what are the components of air? What are the components of air? And in those components of air, which ones are variable? Of air, I want us to list the components of air. After listing the components of air, which are not constant, which are variable. Yes, ndaka tuanzie hapo. Components of air which are variable. So let me start with Timothy.
Components of air is oxygen, nitrogen, inert gases, water vapor, and dust particles.
Thank you. You've mentioned all of them. Amongst the ones you have mentioned, which one are variables? Are variable, they are not constant. They vary from place to place.
Water vapor and dust particles.
Yeah, water vapor and dust particles. It depends with the time and the place. Some places it's evergreen, so the water vapor is high because of the high rate of evaporation of the leaves. And these green places, they have low dust particles. Yes, so that was our first opener question. Now, I want us to talk about this question. I want us to start by, somebody mentioned oxygen, nitrogen, carbon dioxide, dust particles, inert gases, and water vapor as the components of air. There are some which are highly useful than others. For example, nitrogen and oxygen, they are highly useful compared to the others. Now, what do we call the process of obtaining nitrogen from air? What do we call the name of the process of obtaining nitrogen from air? What do we call the name of the process of obtaining nitrogen from air? Good. Yes. While I'm gonna type, please can you type faster kidogo? Those who are typing, type faster kidogo. What do we call the name of the process of obtaining nitrogen from the air? Then I will ask now some questions based on the name of that particular process.
Fractional distillation of liquefied air.
Yes, it is called fractional distillation of the liquefied air. Now, listen here. I'm explaining the process, but in the process of explanation, I will be asking you questions. The name of the process of obtaining nitrogen from air is called fractional distillation of liquefied air. The air is first passed through electrostatic precipitator. The air is passed through electrostatic precipitator. What does electrostatic precipitator removes? What does electrostatic precipitator removes? What does it remove? What does electrostatic precipitator remove? Juliet? Juliet? Timothy?
It removes dust particles.
It removes the dust particles. Name the other process that can be used to remove dust particles apart from electrostatic precipitator. Juliet? Timothy? Madam, it's Juliet? Yeah, the air can be filtered. Now, after that, the air, which is now free of dust particles, is passed through concentrated sodium hydroxide solution. It is passed through concentrated sodium hydroxide solution. Name the component of air that is removed by a concentrated sodium hydroxide solution. Well, you don't want to type. Yes, Timothy?
Carbon dioxide.
It removes carbon dioxide. Name the other component of air. Name the other substance apart from concentrated sodium hydroxide that can be used to remove carbon dioxide. Apart from sodium hydroxide solution concentrated, what is the other substance? Yes, Juliet.
Potassium hydroxide.
Yeah, we can use potassium hydroxide. Thank you. Now, the next stage is we want to remove water vapor. How do we remove water vapor from? How do we remove water vapor from the air? How do we remove water vapor from the air? How do we remove water vapor from air during electrostatic what? During this liquefaction of air. Juliet?
By cooling the remaining part of the air.
By cooling up to what temperature? You just said cooling. Can you mention the temperature in which we are supposed to cool this part of air so that the water vapor can be removed? Yes, the air is cooled to negative 25 degrees Celsius, and in the process, water vapor solidifies out as ice. It solidifies out as ice. It solidifies out as ice. Gonna swallow Juliet. Yeah. Now, we are... Sema? Unasemaje? Okay, so now we have removed water vapor, dust particles, carbon dioxide. The next one is oxygen. How do we remove oxygen from or as a component of it? How do we remove oxygen? And by the way, there are two ways in which we can remove oxygen. Either we remove at the initial stages right now or later on. But I want us to see how do we remove oxygen in this process. Somebody? How? No one knows how to remove oxygen. Timothy. Juliet. Oi. Timothy, are you sure you don't know? I will not ask you that question again. Now, oxygen is removed by passing the air through a heated copper. The copper should be heated. And when the copper is heated, it reacts with oxygen, so leaving nitrogen and argon alone. I would have asked another question why we don't use copper, we don't use magnesium, but we use copper instead. But I know nobody will answer me, so let me answer it directly. If we use magnesium will react with both nitrogen and oxygen, so we only use copper because copper will react with only the oxygen. So that is the point, and that's what you need to get it very well. Now, we call it argon, like in you are, can we hear the R? Yes. You are is also argon, and what we call nitrogen. So these are gases, but before we carry out the last stage of fractional distillation, we need to convert them to liquid. How do we convert the mixture of the gases into liquid? That's a question that I'm asking. How do we convert the mixture? Just type. I'm accepting typing right now. And if 1 minute or 40 seconds elapses, I will know that hakuna mtu anajua, and I will answer it. So I'm just asking, how do we convert? How do we convert that mixture of air in to liquid? I'm assuming you are right now typing. I'm assuming you are right now typing. I'm assuming you are typing. Yes. Yes. So how do we do it? Okay. No one has typed. Let me see if. Okay. Timothy Nzema, by cooling it to negative 200 degrees Celsius, which is okay, no problem. So we convert the air mixture into a liquid air by doing these two things. One, cooling it to negative 200 degrees Celsius. Number two, compressing it to 200 atmospheres. So you cool to negative 200 degrees Celsius, then you compress to 200 atmospheres. Then from there now, we have our liquid like this one. A mixture of argon and nitrogen. And if oxygen was not removed, it will be part of it. So there are three. Now, we carry out what we call fractional distillation. And in fractional distillation, we always remove, starting with the one having the lowest boiling point. So in our case, oxygen, argon, and nitrogen, which one has the lowest boiling point? Which one has the lowest boiling point? Between nitrogen, oxygen, and argon, which one has the lowest boiling point? Juliet? It is nitrogen with a boiling point of what is the boiling point of nitrogen gas when it is in liquid state?
Negative 196 degrees Celsius.
Yeah, it is negative 196 degrees Celsius. Followed by, we have three. We have nitrogen, oxygen, and argon. Followed by, which one follows nitrogen? Hey, do you can't hear me? What could be the problem? Yeah, Pauline, the boiling point is negative 196 for nitrogen. ongeza volume zaidi. Now I'm asking, what comes next after nitrogen? It is argon at negative 186. Then lastly, the oxygen at negative 183 degrees Celsius. Yes. Now, let me ask another question. Unless you have a question, allow me to move away from that. I want to ask another question here right now. Are you ready for me to ask another question? Yeah, I think Pauline, you've arranged them very well. Are you ready? I ask another question, and the questions I want to ask next is about rusting. We all know rust. What is the chemical name of rust? What is the chemical name? What is the chemical name of rust? What is the chemical name of rust? Yes, let me see what Kukul wanasema nini. Hydrated iron 3 oxide, that is from Timothy. That's very correct. Pauline is saying that it is called hydrated iron 3 oxide, which is very okay, kabisa. Rust is hydrated iron 3 oxide. My next question. What is or what are substances necessary for rusting to occur? Name 2 substances necessary for rusting to occur. Good. Just type very fast. Name 2 substances necessary for rusting to occur. Yes, somebody has given us the answer: moisture and oxygen, or water and oxygen. That is okay. Another question. 2 substances that accelerate rusting. Unajua kuna 2 that are necessary, then we have 2 which are accelerating rusting. What are the 2 substances which accelerate rusting? I'm waiting for one person to give us the answer so that we can proceed. Timothy na Julia, tumeamua mtajibu hiyo swali. Because I've received the answer, it is salt and acids. Salt and acids. So if you ask, name two conditions, unasema salty conditions and acidic conditions. Lakini if they ask, name two substances, you will talk of salt and acids. The third one is high temperatures. High temperatures. Give a reason. These are a very common question. I know you've seen it or you've heard it. Give a reason why cars rust faster in Mombasa than in Nairobi. Why they rust faster in Mombasa than in Nairobi. Timothy, give us the answer.
Because of the salty conditions in Mombasa, so they accelerate the rate of rusting.
Yes. Salty conditions in Mombasa. You know one ingine. There are two factors. Ukifika Mombasa magari zina rust haraka sana. Ingine ni gani? Apart from salty conditions in Mombasa, the other one? The other one is high temperatures in Mombasa. High temperatures in Mombasa. Now, we are stating 4 ways of reducing or preventing rust. 4 ways of preventing rust. Pauline, your answer ndio inafika, and that is very correct. There are high temperatures in Mombasa. Our next question is state 4 ways of rust prevention. If you're in class, state 4 ways of rust prevention. Dinda, your answer is received high temperatures, which is very correct. Yes, I'm waiting for you. Kila mtu state yake moja tu. I know we cannot state the same thing. Just write one. We are 4 in class. Oh, okay, we are more than 4 in class. So, just state any way of rust prevention. Timothy, just a minute. Timothy, just type there. Sitaki ndaka kwanza hao wengine wa type haraka. I've received from Pauline, I've received from Eunice, I've received from Juliet. Who else is still sending? We have very many. I'm still giving a chance to one person when anatuma yake. One person? Ikasemaje?
Inakuwa dormant. Nimemaliza particular dormant.
Then after After giving ways of preventing rust, the next question is advantages of rust and disadvantages of rust. I'm giving you 2 minutes. There's something I'm doing behind this camera kidogo too. So advantages of rust and disadvantages of rust. So let me start by, I was handling somebody there. You know, I also do other students on that side who have come to my office, and there's something they're doing. Hata wewe kama uko around unakuja na kuprintia exam, then you do it in our office, so then we mark for you. So that's what we were doing here in Limuru. Unakuja unasema mimi nataka exam ya chem ama physics ama maths ama English, tunakuprintia, you go do it. After doing it, you bring it back to us. So let me start with the answers of Pauline. Painting, coating with other metals through galvanization and electroplating, alloying, oiling and greasing, all of them are very correct, but I would like somebody to differentiate between electroplating and galvanization. Eunice is saying painting, alloying, oiling and greasing together with galvanization. True. What is alloying? I will explain that. Before we get to the advantages and disadvantages of rusting, something here. Let me explain the difference between electroplating and. Look at this phone hivi. Ukiangalia hii simu vizuri, kuna hii cover na kuna simu yenyewe. Of course, mnaweza kumana cover kwa simu, it's to give beauty to the phone. But now, if this is a metal, which is iron, then I take another metal which cannot undergo rust, and I place it this way. That is electroplating. You coat a metal with another metal. Now, let me explain galvanization. You can see these keys. Hii ni kifungu. Hii kifungu ukiangalia vizuri inakaa shiny. Hata unaona inakaa ka shiny. This kifungu haikufanyiwa electroplating, ilifanyiwa galvanization. It was dipped in a solution of zinc. Yani zinc is melted mpaka ina melt vizuri, then unachukua hii unaidip ndani na unaitoa. So to galvanize is to put a very thin layer. It is done when it is in molten state. Alloying is mixing two metals like iron and another one so that it cannot undergo rust. Oiling and greasing, you smear iron with oil or grease, then it will not rust. All these they do, or they prevent rusting in one way, by preventing contact between the factors necessary for rusting, that is oxygen and moisture. Thank you. Advantages of rusting. Galvanization, Pauline amesema it's cotton using sedimentary, which is very true. Now, no, kwa mtu kwa nini mpaka kwa hospitali, ni not hospitali, ofisi ya NHIF, ofisi ya kwa cyber tu ni kuregister. Kuat mpaka aende kwa ofisi ya NHIF pale Njengi Plaza. Hawezi add kwa cyber, sawa?
Mimi nimeregister tu.
Hiyo ni kuregister. Lakini kuat ni mpaka kwa ofisi ya NHIF. So the advantages or the advantage of rusting is this. It helps in decomposition of metal waste. Helps in decomposition of metal wastes. The one that Pauline is saying helps to get rid of scrap metals from the environment. Yes, it helps in decomposition of metal or metallic wastes. Number 2. Number 2, the political. It can either be true or not true. It can either be true or not true. Why? If I say the advantage of rusting, it helps to create job employment for those people who are required to paint the roof. Ukishaona roof imerust, unakuja una paint. Is it true? Disadvantages is they are very expensive. They are very expensive. Eunice Linda, sacrificial production is one of them. It is one of the methods of preventing rust. Yes. So the disadvantage is it's expensive to replace the corroded iron sheets, parts of the vehicle when they may rust. It is expensive. That is the disadvantage. And I want to swallow before we proceed with the questions. Yes, so sawa. Hata kama kuna mtu ana swali, we can proceed. Now, another question that I want to ask. Listen here. Magnesium was found in air. And the products were added to water, or water was added to the product. It was get to my process. Magnesium was found in air. The products were added water, and it formed a solution. A red and blue litmus paper were dipped into the solution formed. State the observation made. State the observation made. State the observation made. Are you getting my question? Yeah, magnesium was heated or was found in air, After kuwa burned in air, waka add maji kwa the products. After ku add maji, wakaweka what we call a red and blue litmus paper. What was the observation made? Yes, what was the observation made? Nangoja reply. The same. Sulfur was burned in air. Let me read the reply from one of you. The red litmus paper turns to blue, and the blue litmus paper remains blue. Correct. The reason is, when a metal burns in air, and that product is soluble, like magnesium oxide, it forms a basic solution, which is magnesium hydroxide. Now, let's use sulfur. Sulfur was burned in air. After being burned in air, blue and, after being burned in air, we added water. Then blue and red litmus paper were added, or were put into it. What was the observation? What was the observation? Yes. You nataka mniambie. Kuna mtu the blue litmus paper changes to red and the red litmus paper remains red. Great. You know why? Because non-metals like sulfur, nitrogen, phosphorus, and carbon, they burn in air to produce acidic substances. When you burn carbon in air, it gives you carbon dioxide. When you add water to carbon dioxide, it gives you weak carbonic acid. So non-metals burn in air to give you products which, when added water, they are acidic. For metals, it gives you basic substances. Hapo tuko pamoja. Another question is this. A comment in the change of the mass when copper was heated in air. Comment on the change in the mass when copper metal was heated in air. What do you say? Comment in the change in mass when copper metal was heated in air. What will you say? Na wangojea mniambie. The mass is increases. Why? Because when copper is burned in air, oxygen is added into it. So the mass increases. Now, I have another question. Listen to this. A pot put copper and magnesium were burned in air, it was realized that there was a greater increase in mass for magnesium than for copper. Like you have to, in magnesium, in copper, you heat or you burn the two in air. Then magnesium registers a higher increase in mass than copper. What could be the reason? It's a good question. I would like to. Eunice, I'm asking a simple question. Nasema hivi, you have 10 grams mass of copper and 10 grams mass of magnesium. The two of them are heated in air. Then it was realized that there was a greater increase in mass of magnesium than that one of copper. Explain. Watu wanasema because magnesium is more reactive than so. Your statement sio final. So because it's more reactive then so can you say it is? Let me explain the point of Beverly and Pauline. Magnesium is more reactive than copper, and therefore it will react with both nitrogen and oxygen. Remember, copper will only react with oxygen, but magnesium will oxygen. Number two. Okay, let me note. Oxygen is available for both. Are you together? Someone is asking what is the difference between sacrificial protection and electroplating. Let me explain. If I use a more reactive metal, let's say these two, this is the iron. If I use a more reactive metal like zinc or magnesium, it will be called sacrificial protection. But if I use any other metal, especially the less reactive one, it is called electroplating. Yes. Digest that one very fast. We proceed. I want us to give 3 ways of preparing oxygen in the lab. 3 ways of preparing oxygen in the lab. 3 ways of preparing oxygen in the lab. Kila mtu alete yake. And because we are over 10, kila mtu alete yake. Which method? Okay, we have 3 methods. Okay, we have 4, but in form 1 we are only giving 3. So give one method. Each one of you are kipeana. In the process, we will give all of them. Just give what you are thinking in your head as one of the ways of preparing oxygen gas. Hiyo ndio tutafanya for the next 4 minutes. Methods of oxygen preparation. Nimepata reply from Pauline, lakini sasa bado nataka reply za watu wengine so that we can check on all of them at the same time. One minute remaining before we give. Aya, tuanze ya kwanza. Let me read now your comments. Chanianze na Pauline anasema catalytic decomposition of hydrogen peroxide. Which catalyst are we using? The same person anasema thermal decomposition of potassium manganate 7. Eunice Ndinda anasema decomposition of hydrogen peroxide in presence of manganese 4 oxide. Pauline Mogusu again is saying adding water to sodium peroxide. Kuna moja amesema lakini wacha tuseme. Ama imesema gani? Oh yes. One, we will not, or we may not write the chemical because I'm just mentioning using manganese 4 oxide to break down hydrogen peroxide. It will give you oxygen and water. Or number 2, adding water to sodium peroxide. It gives you sodium hydroxide and oxygen gas. Then lastly, by heat, HEAT, by heating potassium manganate 7, or simply potassium permanganate. It will give you potassium, manganese 4 oxide and oxygen. You can write them down. Swali ingine, unless kama kuna mtu akona swali. Yes, sasa Eunice Ndinda amenipea ile point ya form 2. In form 2 it says that when nitrates are heated, they give nitrite and oxygen gas. That is, if you decompose sodium nitrate, it gives you sodium nitrite plus oxygen gas. If you are in form 1, don't worry, hiyo tutawafunza. Lakini if you are in form 2, tumewafunza about the action of heat on nitrates. So potassium nitrate and sodium nitrate, when they're decomposed, it gives sodium nitrate plus oxygen gas, potassium nitrate plus oxygen gas. Good. Now, time for me this answer to this question. Kuna swali nataka nikupatie. Testing for oxygen gas. Test for oxygen gas. Test for oxygen gas. Give a statement on how oxygen gas can be tested. Our question is test for oxygen gas. Test for oxygen gas. How do you go about for the test for oxygen gas? Nimepata reply moja. The chemical test for oxygen is it relights a glowing split. It relights a glowing split. Give me 5 physical properties of oxygen. Give me 5 physical properties of oxygen. 5 physical properties of oxygen. In this manner, the color 1, the smell 2, the density in relation to air 3, solubility in water, and the nature. Nature means whether it's acidic or basic. Thank you, Eunice. That's the correct way of testing for oxygen gas. Now we are on physical properties. Physical properties of oxygen. Then I will give one more question and we end there for today. Any here? Abataki kuniambia Steph, oh, I know it's a long one. I know people are typing. Physical properties of oxygen. Alafu tumalizia na the uses, but for now we are dealing with physical properties of oxygen gas. Timothy, type yours. We are supposed to be giving 5 of them. Dinda amepeana tu moja. Kila mtu amepeana moja moja, then I will summarize. One minute remaining. Let me now give those properties very fast. Number 1. What is the color of oxygen? It's colorless. All those when you mention colorless, you are very correct. What is the smell of oxygen? It is odorless, odorless, odorless. What is the density of oxygen? Same density of air. Are we together? It has the same density as that of air. What is the nature of the gas? It is a neutral. It's not acidic or basic. It is slightly soluble in air, meaning it is not soluble. Tumesahau kani? Sunweke kukangalia. Sindika moja tu. Sawa, tutashukuru. Alafu blow dry nitakutumia, tutaongea kesho. Kuna ingine tumesahau kweli? Hakuna yenye tumesahau. I think it's okay. Last question for the day. Uses. Did you use? Uses of oxygen. Uses of oxygen. There are very many. Kila mtu andike mbili moja tumalizie. Uses of oxygen. Yes. Uses. Type yako tu moja haraka. That's our last one. Then I sign out. We meet tomorrow. Uses of oxygen ni gani? Well, you answer Pauline study. Yeah, we are just given the uses of oxygen, then that's where we will end today. So let me give you uses of oxygen. Pauline, I've received 2 answers. Linda, I've received 2 answers. Now let's check. There are very many, but I'm giving you just some of them. Zingine utazijitafutia. During steel making, oxygen is used to remove impurities of iron. During steel making, oxygen is used to remove iron impurities. Oxygen is used as one of the reactants in the fuel cells. Oxygen is used as one of the reactants in the fuel cells. A mixture of oxygen and acetylene flame burns to produce a very hot flame used in welding and for cutting metals. Oxygen is used in hospitals by patients with breathing difficulties. Oxygen mixed with helium can be used by deep sea divers and mountain climbers. Those are the uses of oxygen. I hope we are okay there. Allow me to sign out. Thank you for watching us. Thank you for visiting our channel. Thank you for learning through us. We hope that by any time you sign here, you get out when you are changed, when you have gotten a point which you didn't know, and you will still come back. We watch together. We learn. Tomorrow at 2 p.m. we shall be doing physics all the way up to 4. I wish you a nice day. I wish you a nice day. Keep on following us. There is no, it's good we learn chemistry together. Have a nice day.